everyone. Today we're going to talk about the probability of mutually exclusive events. And so we're going to start with the notes and then we'll do a couple of problems from the assignment together. So we're just going to play fill in the blank. To determine the probability that one event occurs or another event occurs, we need to determine whether the two events are mutually exclusive, which means do they happen at the same time or are the events independent of each other. So what does mutually exclusive mean? Mutually exclusive means that the two events blank happen at the same time. So they cannot. If they are mutually exclusive, they cannot happen at the same time. This means that the two events would have no blank in common, which means there is no blank. I don't like filling blanks. So they have no outcomes. No outcomes in common, and there is no overlap. Okay? All right. Two events are not mutually exclusive if they blank happen at the same time. Okay. So if they can happen at the same time, they are not mutually exclusive. Meaning there is blank in the sample spaces. There is overlap. Okay, so mutually exclusive means that the two events do not happen at the same time. All right, that's what we have to remember. Two events that are more, but they do not happen at the same time. Okay, so when we're finding the probability of mutually exclusive events, we add each individual possibility. So you would have the probability of the first event plus the probability of the second event. So we add the second event, not A, we add those together, okay? That's all we do. All right, so at lunch, a local college recruiter is drawing names for prizes to determine whether the events are mutually exclusive or not mutually exclusive. So the first one, a student chosen to be a senior, chosen being a senior or being a junior. So those two events do not affect each other. You can either be a senior or you can be a junior. They do not overlap. So this one is mutually exclusive. On B, a student being chosen being an athlete or being a female, well, that could be the same. The athlete can be a female, or the female can be an athlete. So that is not mutually exclusive because that can happen at the same time. All right. So number 2, James drew a marble out of a bag with 3 green marbles, 4 red marbles, 1 white marble, and 6 orange marbles. What is the probability he drew a green or a white marble out of the bag? So first of all, how many total marbles are there? So we have 3, 4, 1, and 6. 3, 4, 1, and 6. 7 and 7. So there are 14 marbles. Okay, that's our total. What's the probability he drew a green or a white? So the probability of green or white. So we're going to do the probability of green and add that to the probability of white. So there are 3 out of 14 plus 1 out of 14. So 4 out of 14. Simplify that. So that's 7. I'm sorry, not 7 on top. That's 2 out of 7. So the probability of getting the green or the white is 2 out of 7 because those events are mutually exclusive. Okay, you can't, they're two different things. All right, so number 3. Mac drew a card out of a standard deck of cards, the probability of a 5 or a jack. All right, so I'm gonna work that one up here. So the deck of cards has 52 cards. So the probability of a 5, well, how many 5s are in a deck of cards? There's 4, so that's 4 out of 52. The probability of a jack, and there are 4 jacks, so that's 4 out of 52. You can't get a 5 and a jack. Those don't go together, so those are mutually exclusive. So we have 8 out of 52, and if we simplify that, let's see here, 4 is 52 divided by 2. 2, 4, 12, 2 out of 13. So 2 out of 13 probability of a 5 or a jack. Okay, so the probability of non-mutually exclusive events. So we're going to talk about this a little bit, but it's not the big part of what we need to know with mutually exclusive events. The probability, to find the probability of 2 non-mutually exclusive events, you start by blank the probabilities of each individual event. All right. So we're going to add. We start by adding the probability of each individual event, but then you must take away, subtract, blank, which are the outcomes that are blank between the two events. Okay, so we start out by finding the probability of A and the probability of B, and then we take away the probabilities that they have in common. Okay, so let me get those words for the fill in the blank for you. Overlap, and any outcomes that are shared. All right, so we're going to subtract the overlap. This is the overlap. Okay. All right, so let's see what that looks like. We'll do that together. Okay, so what is the probability of drawing a queen or drawing a spade out of a standard deck of 52 cards? Okay, so a queen can also be a spade. So that's where we have that these are not mutually exclusive. So we're going to do the probability of the queen plus the probability of a spade, and then we have to subtract the probability that it's queen and spade because it can be both. So we have 4 queens in the 52 cards. We have 13 that are spades. Okay, and then we have to subtract that we have 1 that is a queen and a spade. Okay, so we have 17 minus the 1, which is 16, and then we're going to reduce that. So that's 4, 52 divided by 4, 1, 4, 12, 3. So that's 4 out of 13. 4 out of 13. Okay? All right. A 6-sided die is rolled. What is the probability you roll an even number or a number that is greater than 3? Okay, so we have 1, 2, 3, 4, 5. Those are our outcomes. We want the probability that we roll an even number and the probability that we roll a number greater than 3. And then on that, we have 2 numbers that are both even and greater than 3. So we have to subtract the probability for both, okay? So we have evens, we have 3 out of 6. We have 3 out of 6 that are greater than 3, and then we have 2 out of those greater than 3 that are also even. So we have to subtract the fact that we have those 2. All right. So we have 6 minus 2, which is 4 out of 6, which is 2/3. Okay, so that's our probability for that one. All right. Okay, so then we have the complement of an event. And so a complement occurs when, what's the probability if it's 20% chance of snow, what's the chance that it's not going to snow? So it's the 80%. That's what complement of an event has to do with. There's 2 different kinds here. We're going to be focusing on this kind, but we'll get this blank filled in too. All right. So the complement of an event exists of all the blank in a sample space that are not included as outcomes of the event. All right, so all of the outcomes. Okay, so the probability of it not being the event, so the whole probability, which is 1, minus the probability of that event occurring. All right, and then there are some situations that we want to find the probability of an event occurring at least once. An event occurring at least once is the complement of an event never occurring. Okay, all right, so let's take a look at what this looks like. Okay, we will look at that here in a minute. Maybe. I can't remember if I put that on there or not. No, I think you're going to do that on your own in the assignment. But if you have questions, just come ask me. All right, so Matt rolled 2 6-sided dice. What is the probability that he rolled doubles, or that the sum of the 2 dice is 8? Hint, you may want to make a table for the sample space for the sum of the 2 dice. All right, so we need the probability of doubles or a sum of 8. And that could overlap, right? So that is not mutually exclusive. So we're gonna find the probability of doubles plus the probability of a sum of 8, and we have to subtract the probability of both. Okay, so let's look at those outcomes. I'm not going to make a table, but I am going to make a tree diagram. So our outcomes, we have 2 dice. So if you roll the first one, the outcomes are 1, 2, 3, 4, 5, and 6. And so on the second die, you have 6 outcomes. 1, 2, 3, 4, 5, 6. On this one, you have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. All right, so 2 6-sided dice, and these are the possible outcomes. And so there are 36 total. All right, so out of 36 and out of 36, and then we're going to subtract from the 36. Okay, so how many possibilities do you have that you could get doubles? Well, you could have a possibility here, 1 and 1, here 2 and 2, here 3 and 3, here 4 and 4, here 5 and 5, and here 6 and 6. So there are 6 possibilities of getting doubles. Then what's the probability that you could get a sum of 8? On this roll, you can't get a sum of 8. So there are no possibilities here. On here, you could have 2 and 6. Here you can have 3 and 5, 4 and 4, 5 and 3, 6 and 2. So there are 5 possibilities that you could get the sum of 8. And then with that, there's the one possibility here at 4 where you can get doubles and the sum of 8. So we're going to subtract that one. So we have 11 minus 1, which is 10. And then simplify that. 5 out of 18. So that would be our probability for rolling doubles and the sum of 8. All right. Okay, so on number 2, a card is drawn out of a standard deck of cards. Find the probability of a heart or a jack. So we're going to find the probability of heart plus the probability of a jack, and we have to subtract the probability that it could be both because jack can be a heart. So how many hearts are there? There are 13 out of 52. How many jacks are there? There are 4 out of 52. And then there's one card that's a heart and a jack. So we're going to subtract that one. So we have 17 minus 1, which is 16 out of 52. Reduce that. 52, not 54. 52. We did this a second ago and I forgot. 13. 4 out of 13. So that's our probability to find the answer for 13s is the probability of a heart or jack. Okay. Avery has 3 different types of songs on her music playlist as shown in the table. If the playlist is on shuffle, what is the probability? The first song will be either a Disney song or a hip hop song. So first of all, how many total songs do we have? 8, 6, 1, 7, 8, 9, 10, 11, 12. There's 126 total songs. And so we want the probability that it's Disney or hip hop. Okay? And those things don't overlap, so it's mutually exclusive. So we're going to find the probability of Disney and add it to the probability of hip hop. So Disney is 68 out of 126. Hip hop is 24 out of 126. 68, 24, 12, 9. 92, and then they're both even, so we can reduce those. 92, 4, 8, 12, 6, 46, 126, 6, 12, 6, 3, 63. Can that reduce again? Let me check. Nope, this is where we are. So the probability that it's a Disney or a hip hop song is 46 out of 63. Okay, so before I end the video, real quick, I want to go back to that complement. So the probability of it not being an event. So again, you subtract that from the whole. So if you wanted like I said earlier, the probability that it's going to snow is 20%. 20% chance of snow. So what's the probability that it's not going to snow? So you take the whole amount and subtract it. So if it's 20%, that would be 100 minus 20, so it's 80% chance of snow. And you would do that just with your numbers also. If it's, instead of 20%, maybe it was written as 0.2. So 1 minus 0.2 would be a 0.8, okay? You just subtract it from the whole, and the whole being 1, because if the chance of something always occurring is 100%, and so we write that as a 1. If you remember, a probability is anything from 0 to 1. So that's what I have on mutually exclusive events. So on your assignment, you're going to finish it up with 4, 5, and 6 on your own and get that turned in. Have a great day.